This is part one of a review of congruence. In this video we will focus on complementary versus supplementary versus congruence, and we'll work with linear pairs, vertical angles, and parallel lines cut by a transversal, and explore those relationships. Alright, so in problem number one, we're given that the measure of angle A is 68 degrees, and A and B are complement of each other. They're complementary. A and C are supplementary. Find the measure of B and the measure of C. Okay, well, if A and B are complementary and angle A is 68 degrees, so you need to understand that complementary means adds up to 90. Okay, that's what complementary means. So if A and B are complementary, all you have to do is subtract from 90. So to find the measure of angle B, that's going to be 90 minus 68. Okay, so that's going to be 22. So the measure of angle B is 22 degrees. Now on the other hand, A and C are supplementary. Now supplementary means that they add to 180. Okay, so again, we know that the measure of angle A is 68 degrees. So if I want to find the measure of angle C, I need to subtract from 180 because they're supplementary. So 180 minus 68 should give me the measure of angle C. And that's 112. Okay, so B is 22, C is 112. 22, 158? No. 22, 112? Yes. So that's why the answer is B. Okay, problem number two. We're supposed to solve for X and Y. Well, if you look at these two angles right here, these two angles form a linear pair. See how they form a straight line right next to each other? You can almost see the semicircle here. Together, these have to add up to 180. They are supplementary. Okay, so in other words, you could think of it this way. 75 plus 3x, that has to equal 180. So you could subtract 75 from both sides, and that would tell you that 3x is equal to 105. And then you could divide both sides by 3. Okay. Alright, that's 35. Alright, so X is 35. Now, let's look at the angles that are right across from each other. The 75 and the Y plus 30. These are vertical angles, and vertical angles are always congruent. And so that means that the Y plus 30 should equal 75. So you could just subtract 30 from both sides. Alright, so that's going to be 45. So x is 35, y is 45. Alright, so that's A. Alright, number 3. Can you prove that lines P and Q are parallel? If so, state the theorem or postulate that you would use. Well, we see that these angles are congruent, so what kind of angles are these? These are corresponding angles. So we know that the lines are parallel. If corresponding angles are congruent, then the lines are parallel. Alright, alternate interior, no. Yes, because corresponding angles are congruent. So that's the answer. Number 4. Okay, AB is an angle bisector of CAD. How would you find X? Okay. If AB is an angle bisector, then that means that, hold on. Alright, there's some extra lines in there that were bugging me. Bisector means to split something in half. So if AB is an angle bisector, it's splitting the larger angle into two equal halves. So that means that the 3x should equal the 2x plus 25. So that would give you this equation in D. So that's why D is going to be the answer. Okay. Looking at number 5. M is the bisector of AB. So again, that means these will be two equal halves. AB is 5x minus 2. So that means this whole thing is 5x minus 2. AM is 2x plus 1. Okay, so that means this is 2x plus 1. How do we find x? Okay, well, if AM is 2x plus 1, that means MB is also 2x plus 1. Okay, so if I compare the blue expressions with the purple, okay, the blue expressions, there's two of them. So if I wanted to find the whole distance, I would have to add these together. And basically you wind up combining your like terms here. So this side is the same thing. Combining your like terms, this gives us 4x plus 2. Okay, so on the blue side we have 4x plus 2, and on the purple side we have 5x minus 2. So 4x plus 2 should equal 5x minus 2. Okay, and that's what we have here for option D. 4x plus 2 is equal to 5x minus 2. So we could solve this using equation D. Okay. Number 6. This is an isosceles triangle. That means that the base angles are going to be congruent. So angle B is going to be congruent to angle C. Okay, so if angle A is 14x, okay, angle B is 20x plus 9. Alright, and angle C is 23x. Okay, which one is not a way to solve for x? Interesting. Okay, let's see what's going on here. So I see 14x, alright, and then 20x plus 9 and 23x. Okay, that would be the sum of each of these three angles. Should these three angles all add up to 180? Yes, alright, and all of the angles of a triangle should add up to 180. So that is a way. So that's not the answer. Let's look at the next one. We have 2x plus 9, and that's set equal to 23x. Well, 2x plus 9 and the 23x, those are the base angles of the isosceles triangle. So those are congruent, so those should be equal. So that's another way to solve for x. So that's not the answer. Let's see what's going on in C here. We have the 2x plus 9. I'm sorry, the 20x plus 9. Okay, that's that angle. And then we have the 23x. That's this angle. And that's equal to 180 minus 14x. Okay. Well, that is the same thing as A. Okay, the only difference between A and C is that they have subtracted 14x from both sides. So minus 14x minus 14x. Okay, that way these will cancel out, and you're left with 20x plus 9 plus 23. See how those all match? And equals 180, and then minus 14x. Okay, so A and C are the same, so that still is good. So that leaves D. So let's look at D and understand why that's not the answer. Well, let's look at D and see why that could not find x, and that is going to make it the answer. 14x and 20x plus 9. That's these two. There's no reason why these two angles should be equal. Okay, they are not going to be congruent. So D is the one that is not a way. So that's what we were looking for. Okay, LM is a mid-segment of the triangle, and we're supposed to find JK. Alright, so JK is down here, so that's what we're trying to find. But if this is the mid-segment, so that means this is a midpoint, so that means these two sides are congruent to each other. Alright, but it also means that this bottom, the base JK, is double the size of the mid-segment LM. So for example, if this turns out to be 10, then this would be 20, for example. Alright, but first we have to find x by setting these equal to each other, since L is the midpoint. So let's get that done. So 7x should equal the 3x plus 4. So you subtract 3x from both sides, and that gives you 4x is equal to 4, and then you divide both sides by 4. So that gives you x is equal to 1. So now that we know that x is equal to 1, we can take that and substitute it in. Okay, so that just makes this 2 times 1 plus 6. Alright, so that's going to be just 2 plus 6, so that's 8. Alright, so LM is 8. So JK has got to be twice as big, so this is going to be 16. Alright, and I think it's multiple choice, so 16 is option D. Alright, let's take a look at number 8. Okay, we are being given that segment QN is congruent to segment QM. Alright, if those are congruent, then that means that the blue triangle is congruent to the pink triangle by side, side, side. Because, I mean, look at all the rest of the lengths with the 3.6s, and of course they share this part, so that's going to make the bases equal. The 1.8 is congruent to the 1.8, and the 4 plus the green mark, 4 plus the green mark, those are equal. So all three sides are congruent, so the bottom line is the blue triangle is congruent to the pink triangle. So with that in mind, somehow we're supposed to find the measure of angle LQO. L to Q to O is this angle right here. So this is our target. That's what we have to find the measure of. Alright, so let's see what we know. Well, we know that this is 86 degrees. So this is going to be 86 degrees over here. Okay, that's 75 degrees, so this is going to be 75 degrees. Alright, so if we know two angles in a triangle, then we know a third, because we can just subtract from 180. So let's do 180 minus these two to figure out what the corner piece right here is. So 75, 86. That's 19 degrees. Alright, that means this corner is 19 degrees. Which means this corner, alright, looking at the pink triangle, this corner is 19 degrees as well. Okay, now looking at the small triangle here, this little isosceles triangle, we have two angles of the small triangle. So that should help us find the third. Okay, so if I subtract these two from 180, that should give me the measure of this angle at the vertex. So if I do 180 minus 19 minus 19, that gives me 142. Okay, this has to be clear. So this is 142 right there. And that is going to be vertical angles with the angle that we were looking for. So this is also going to be 142. So that was quite a little journey, and to be honest with you, when I first started out, I didn't know how I was going to find this angle. But so as a strategy, I think it's a good idea to just start solving for things that you know, and see what happens. See where the journey takes you. So 142 degrees. All right, and that was C. Okay, for what values of x and y are the triangles congruent? So if the triangles are congruent, then let's see. Let's start with these corresponding sides. All right, the 4y plus 2 would be corresponding with the 9y minus 8. So let's set those equal to each other and see what we get. So if I do 9y minus 8 equals 4y plus 2. Alright, first get the variables together. So subtract 4y from both sides. Alright, so that's going to give me 5y minus 8 is equal to 2. Then we would add 8 to both sides. That's going to give me 5y is equal to 10. Then we would divide both sides by 5. So that's going to give me y is equal to 2. Okay, so now we still have to find x. So, but now that we know y, focus on these two expressions, but now we know that y is 2. So we can take this value and we can put 2 in for y. So that makes this become 3x minus 2. Alright, so let's use that. So in other words, these two expressions should now be equal to each other. Let's see, is there room over here? Okay. Alright, so let's set these equal to each other. So 3x minus 2 should equal 2x plus 3. First, let's get the variables together. So let's subtract 2x from both sides. So that's going to give me x minus 2 is equal to 3. Now let's get x by itself by adding 2 to both sides. And that's going to give me x is equal to 5. Alright, so x is 5, y is 2. I have a feeling that there was another answer that got cut off here. Let's see if I can move this up. Okay, there it is. X is 5, y is 2. That's option D. Okay, so that's going to be the answer. I messed up my highlighting. Oh well. Alright, this will be the last problem on this video. Number 10. Which two triangles are congruent by the hypotenuse leg theorem? The drawings are not to scale. Okay, well they're all right triangles, so we're just looking for which one of these has a hypotenuse and a leg that are shown congruent. Well, this is a hypotenuse and this is a leg. So that means A is good. This is a hypotenuse and this is a leg. So that means B is also hypotenuse leg. But wait a minute. The markings. They have a double mark on this hypotenuse, and they have a triple mark on this hypotenuse. Um, okay, I really feel like this is a trick question. Because we do have a hypotenuse and a leg marked, and this is a hypotenuse and a leg also marked. But because the hypotenuses are marked differently, that means that these are not congruent to each other. Okay, so we can't say A and B for that reason. And then C, the hypotenuse is not marked at all. So that was a little tricky. I was all set to say that A and B were congruent. If they had given us the third mark, okay, if they had given us this, okay, hypotenuse leg, then we would have said A and B. But with a double and a triple, those are not congruent. So none of these are congruent by hypotenuse leg. Okay, that's why the answer is going to be D. Okay, kind of a trick question though. Alright, but anyway, that's going to be the end of this video. And so that we'll call that part 1. We still have more of this review yet to come. Let's take a sneak peek into what's going to be in the next video. Okay, in the next video we're going to get into why are these triangles congruent, you know, side, side angle, side, that type of thing. And let's see, what else we're going to get in there. Okay, more mid-segment. Okay, some two-column proofs. So that's what's to come in the next video. See you in part 2.